let's talk a little bit more about the domain and the range. So just to kind of quickly review, a relation is basically a relationship between an independent variable. So it's a relationship between the independent variable, which are the x values, and the dependent variable, which are your y values. There's some sort of a relationship or rule that connects your x's, your inputs, and your y's, your outputs. The domain of a relationship is the set of all of the values of the independent variable. Independent is connected with the domain. In other words, the domain is the set of all of your x values. And I'll put input in here in parentheses. All of your inputs are your domain. The range of a relation is the set of all of the values of the dependent variable. In other words, the range is the set of all of your y values, and I'll put your output values here in parentheses. So just a reminder, domain, x values, independent variables, they're all connected. Range, dependent variable, y values, they're all connected. Let's go ahead and do a quick example so you can kind of see how this works, maybe in a real life scenario. Andrea is selling snow cones over the summer. The first day she sold 5 snow cones and she made $7.25. The fourth day was especially hot. She sold 12 and she made $17.40. Good for her. And the ninth day, not so hot. So she only sold 2 and she only earned $2.90. And it says here, what is the independent variable and what's the dependent variable? Well, at first I might think, well, isn't like the coolness of the day, doesn't that affect how many snow cones she earns? And while that's true, we're really looking for the actual values, like the number values here. And so I'm taking a look and I have the number of snow cones that she sold and the amount of money that she made. Number of snow cones, amount of money, number of snow cones, amount of money. So I have to ask myself, is the number of snow cones influencing the amount of money she made? Or is the amount of money she made influencing the number of snow cones? And the independent variable is the number of snow cones that she sells. So the number of snow cones, there we go, because that's independent, that's influencing or driving how much money she makes. So what is the dependent variable? It's how much money she makes or how much money she earns. And then the second part is, what are its values? Well, the values of the number of snow cones that she sells is, and I'm just going to go in order, it's 5 snow cones. The fourth day is 12, and the next one is 2. Oops, and I'll put a comma. So I put a comma in between each of those values. And then for the dependent variable, again, what are its values? Again, I'm going to go in the same order. So it would be 7.25, and then 17.40, and then 2.90. So then the last part of this is identify the domain and the range of this particular situation. So the domain, I'm just going to write D for domain. And when we're doing domain, just kind of our mathematical way of saying this is the set of all of the numbers, is we like to put the numbers inside these little kind of squiggly brackets. So the domain is the independent variable. So the domain is 5, 12, and 2. And I'm just going to leave them. I'm not going to worry about putting them in any sort of order, like from smallest to biggest. I'm just going to leave them in the order that I saw them in the problem in the days that she sold them. And then range is the dependent variable. So again, I'm just going to do R for range, and I'm going to do the same squiggly brackets. The range, all of the values are going to be inside that squiggly bracket, and I'm just going to write these ones separated by a comma. There we go. So that is the domain and the range of this particular situation. Maybe, you know, she sold other ones on the second day and the third day, but those ones aren't listed, so I don't have them. So the only domain and range I have are what is listed here. Let's go ahead and do number 2. Jeremy is mowing lawns to make some extra cash. Go Jeremy. He charges $5 per lawn. He takes his job very seriously, so he'll only take up to 8 jobs a day, so he has time to do each yard properly. What's the independent and dependent variable? Well, I'm seeing $5 per lawn and number of jobs. Let's see, I have number of lawns mowed and how much he can make. Let's see. Well, does how much he make influence the number of lawns he can mow, or is it the other way around? And in this case, it's the number of lawns he can mow influence how much money he can make. If he can, you know, mow less lawns, then he earns less money, more lawns. So the independent variable here is the number of lawns he can mow a day. And that's going to be my X value. That's my input. And the dependent variable in this case is how much money he can make. How much money he earns. And that is my Y variable. And one thing to consider is the independent variable in this case, there's actually a restriction on it. It's not just an infinite number. He can only take up to 8 jobs a day. So 8 is the maximum value for this independent variable. And they're also whole numbers, they're integers. I can't have half of a lawn, it's one full lawn. So in this case, there's restrictions on the independent variable, and therefore there's going to be restrictions on the dependent variable. I can't get just any value at all. Now we're going to make a graph, and we want to make sure we label everything, we label our axes properly. So I know that here's my x-axis and my y-axis. And my x-axis is going to be my number of lawns mowed. So I'm going to go ahead and label that. Number of lawns mowed. And we'll go ahead and graph these, label everything properly. Now we're going to identify the domain and the range of this particular situation. The first thing I want to just draw attention to is that this particular situation, is it continuous or is it discrete? And it's obvious by looking at it, this is a discrete situation because we might be tempted to connect these points with a line because that's what we've done in the past. But in this particular real life situation, you're not going to be able to connect the points because he's not getting any money for 1.5 lawns. If he does 2 1/3 of a lawn, they're not going to pay him a portion of the money. He just gets all or nothing. So this is a discrete situation because the points are actually not connected. The domain, again, and we're going to put all of our little points in that really awful looking squiggle line. The domain are X values, and in this case, he could mow 0 lawns, so 0 is included. That is a possibility. And then we could have 1 lawn, 2, 3, all the way up to 8 lawns. No more than 8 because he caps it off at 8. And they're all integers because he's not going to do 1.5 lawns or anything like that. The range, again, well, if he mows 0 lawns, he's going to get $0. And then he's not getting any portion, so he's only getting groups of $5. So his range would be there we go. There's his range in those same squiggle marks. And again, his range is they're all integers, they're all multiples of 5. So that is kind of a kind of quick preview of domain and range and what that looks like into real life situations.